In this video, we are going to talk about electronegativity. Now, what exactly is electronegativity? How would you define it? Electronegativity is the ability of an atom to attract an electron to itself. A good example is fluorine. Fluorine is highly electronegative. It has a strong desire to acquire an electron. So once fluorine is given an electron, it's going to acquire a negative charge. And the reason why it wants this electron is it wants to fill its outer energy level with electrons. It wants to satisfy that octet rule. And so fluorine is electronegative. In fact, all of the halogens, like fluorine, chlorine, bromine, they're relatively electronegative. So they want to gain an electron. Sodium, a metal, is not electronegative. If you add an electron to sodium, it's not going to form an anion. Rather, sodium is electropositive. It wants to give away an electron to form a positively charged cation. And so nonmetals tend to be electronegative. They like to acquire electrons. Metals, on the other hand, tend to be electropositive. They like to give away electrons and form positively charged ions. So now, what is the trend with electronegativity? How does it change as you move across the periodic table? Well, let me give you some values first. So I'm going to give you the value for hydrogen, lithium, sodium, boron, carbon, nitrogen, oxygen, fluorine, and some other elements as well, like phosphorus, sulfur, chlorine, bromine, and iodine. So the electronegativity value for hydrogen is 2.1, and for lithium it's 1.0, and for sodium it's 0.9. So notice that the electronegativity increases as you go up across the periodic table. Now what about to the right? Boron is about 2.0, carbon is 2.5, nitrogen is 3.0, oxygen is 3.5, and fluorine is 4.0. Generally speaking, as you go towards the right, it increases. Phosphorus is 2.1, sulfur is 2.5, chlorine is 3.0. As you can see, as you go to the right, even in this row, the electronegativity increases. Bromine is about 2.8, iodine is 2.5. So the general trend is that the electronegativity increases towards fluorine. Fluorine is the most electronegative element on the periodic table. The noble gases don't have electronegativity values. Because they're stable, they don't want electrons. So if you look at the periodic table, if you go to Google Images, type in electronegativity and periodic table, you should see that there shouldn't be a value for the noble gases. Now let's work on some practice problems. Which element is more electronegative? So looking at part A, is it chromium or is it arsenic? Which one's going to win? What do you think? Chromium is a metal and arsenic is a nonmetal. Nonmetals are usually more electronegative than metals. So therefore, we should expect that arsenic is going to be more electronegative. Now the second thing that you can look at is the electronegativity values. For chromium it's 1.6 and for arsenic it's 2.0. And the second thing you could do is place them on their respective positions in the periodic table. Chromium is to the left of arsenic. So therefore electronegativity increases towards fluorine. So arsenic is closer to fluorine than chromium is. So therefore we should expect that arsenic will have a higher electronegativity value. Now what about part B? Let's compare calcium and zinc. Now both of these elements are metals. So we have to look at the respective positions on the periodic table. Calcium is an alkaline earth metal, which is on the left side, and zinc is a transition metal to the right of calcium. So therefore, we know that electronegativity increases as you go towards the right. Atoms become smaller as you go towards the right, and smaller atoms tend to have higher electronegativity values. The electronegativity value for calcium it's about 1.0, and for zinc it's 1.6. So zinc is more electronegative than calcium. Now let's move on to part C. Let's compare selenium and tellurium. Which one is more electronegative? Now both of these elements are nonmetals. In fact, they're chalcogens. So you have oxygen, sulfur, selenium, and Te. We said that oxygen has an electronegativity value of 3.5 and sulfur is 2.5. Now selenium is about 2.4 and Te is 2.1. So clearly Se is more electronegative. Plus, if you place them in a respective position, Se is above Te. Electronegativity increases as you go up within a column. As you go up across the periodic table, the electronegativity values will go up. Selenium is a smaller atom than Te. Now let's move on to part D. Which one is more electronegative? The chlorine cation or the chlorine anion? Which one will you pick? So which one wants an electron? Which one has a greater desire for an electron? Well, let's find out. If we place the chloride ion next to an electron, these two have like charges. And so therefore, these two ions will repel each other. So this chloride ion does not have a desire for an electron. It doesn't want to acquire another electron. However, the chlorine cation is attracted to an electron. Like charges repel, but opposite charges attract. So these two, they will feel a force of attraction, which means the chlorine cation has a strong desire for electrons. So what you need to know is that positively charged ions are more electronegative than negatively charged ions. Ions with positive charges are usually more electronegative than neutral atoms. Not in all cases, but usually. And an ion with a positive charge is definitely going to be more electronegative than an ion with a negative charge, especially if it's composed of the same element. Now, if the elements are different, you have to look at other factors. Because if you compare Na plus with fluorine, fluorine really wants an electron. If it's next to an electron, it will acquire it. However, if you put an electron next to the sodium ion, it doesn't want an electron. It's happy the way it is. So not all positively charged ions are more electronegative than neutral atoms. However, when you compare, let's say, the sodium ion versus the sodium atom, when the element is the same, we should expect that this one should be more electronegative than this one. Even though none of them really wants an electron, the one that has a positive charge is usually more electronegative than the neutral atom if the element is the same. But if the element is not the same, then it's a whole different story. Now let's look at part E. Let's compare the nickel 2+ cation with the nickel 3+ cation. Which one is more electronegative? So which one has a stronger desire to acquire an electron? Now both of these ions may have a desire for an electron, but the nickel plus 3 cation has a stronger desire for an electron because it has a higher positive charge and the element is the same. So when the element is the same, the ion with the most positive charge is usually the one that is most electronegative. The one with the greatest negative charge is usually the one that's less electronegative. Now let's move on to our second question. Rank the following elements in order of increasing electronegativity. So we have manganese, oxygen, copper, phosphorus, and rubidium. So what you want to do in this problem is you want to place them in their respective positions in the periodic table. So rubidium is an alkali metal, so it's going to be on the bottom left. Manganese and copper are transition metals. Phosphorus is a nonmetal, and oxygen is a chalcogen that's also a nonmetal. Now we know that electronegativity increases towards fluorine. Oxygen is right next to fluorine. So therefore we should expect that oxygen should have the highest electronegativity value and rubidium should have the lowest. In fact, oxygen, we know it's 3.5. The electronegativity value of phosphorus is 2.1. Copper is 1.9. Manganese is about 1.5. And rubidium, 0.8. So oxygen is highly electronegative. Rubidium is electropositive. So to rank it in order of increase in electronegativity, we need to write it from the lowest value to the highest value. So we're going to start with rubidium, which is less than manganese, which is less than copper, which is less than phosphorus, and that's less than oxygen. So this is the answer right here. That's how you can rank the elements in order of increase in electronegativity.